So for the project description, like all of you, my project's going to be in Midtown Manhattan. The building footprint goes from 120 by 90 feet on the ground floor up to 168 by 120 feet, back to 120 by 120 feet at the top of level 1, to 72 by 120 feet at the top of level 2, to 24 by 120 feet. I have a floor height, a typical floor height of 15 feet with a ground floor level of 30 feet. So technically my building is 41 floors with a total height of 630 feet. This is sort of what the building would look like with the total facade from multiple angles. All right, structural criteria. I used the New York City Building Code, specifically chapters 16, 19, 22, and 7 for the structural design of concrete, steel, and fire resistance. I used AISC version 16 for allowable deflection and demand versus capacity ratios, as well as ACI 318-19. For the design loads, I had a dead load with a self-weight multiplier of 1. So that really kind of varied throughout the building, but a typical of 56 pounds per square foot. Superimposed dead load of 20 pounds per square foot, a construction live load of 20 pounds per square foot, live load of 100 pounds per square foot, and wind loads that were as per ASC 7-16 with a max wind speed of 115 miles per hour. And the deflection criteria was L over 240 for dead load and live load, and L over 360 for just the live load. All right, for the floor framing system, typical spacing for my columns was 24 by 4, either 24 or 30 feet, depending on the direction you're going, with the beam spanning the shorter distance of 24 feet and the girder spanning the longer distance of 30 feet. My lit metal slab thickness, the actual thickness was 0.035 inches. That's the gauge you were talking about earlier, with a depth of 3 by 3.25 inches, and that's because I was using lightweight 4,000 psi concrete. And the steel was A992 steel with a yield strength of 50 KSI. So this is the typical floor framing plan for level 1, which is floors 1 through 13. My typical beam was a W14 by 22, which you'll see on the system. I broke the building up into 4 components, so that's each level, so every time the building sort of tapers in. I broke that up into different sections within E-tabs so that I could, sort of modularize the design. I wanted to be able to have a varying thickness and concrete strength, but also, we're not going to do it 40 times because that's just ridiculous. So the deflection criteria was H over 500, which came out to be 15.12 inches. And what I actually have here is my shear walls. They become a third of the size come the third level, mostly because the building gets much smaller. And the area that is actually taking the wind load decreases significantly as well. So I started off, like I said, with 4 different sections, as you can see here. And I think the original, it was 24, 20, 18, and 16, or 18 and 12, with 4 varying different strengths of concrete. But what I ended up doing was the first 2 levels have a wall thickness of 24 inch deflection. Then for our my proposed foundation system, it's a mat foundation. It ended up having a thickness of 9 feet with 6,000 psi concrete and an area of 100 by 130 feet, with soil bearing capacity of 20 KSF because it was 10-ton soil, with the subgrade modules of 480 kips per cubic foot. So this is the soil bearing capacity. This is the soil bearing diagram for just the typical dead load and live load. Then we move into the soil bearing, including the wind load. So you can see for the X, it shifted it significantly, and same with the Y, it shifted it significantly. Then for the shear check, the max shear with the strength of concrete was 232 PSI. And you can see really it's pretty scattered, but you can see there are concentrations at some of the key columns where the shear is the highest. And then I did a strip force analysis. I didn't do the finality, I did the strip force analysis. So these are the shear moment diagrams from that strip force analysis. You can see here are moment diagrams, here are the shear diagrams in both the X's and Y direction. The reason I broke them up, it's kind of hard to see if you overlay them together. Then for the flexural bar design, What I ended up going with the concrete beams, the concrete walls, the concrete slabs, and then we have a summary of that here. So total steel tonnage of 2,100 tons with a little bit over 4,000 steel pieces. Total volume of 4,000 KSI concrete of almost 8,000 cubic yards. Total concrete volume of 6,000 KSI concrete, almost 4,500 cubic yards. 1,400 cubic yards of 7,000 KSI concrete, and almost 6,500 cubic yards of 9,000 KSI, with a total concrete volume of over 20,000 cubic yards.